Thank you very much. I'm really lucky to be going after a lot of great talks today, and I wanted to take a moment to reflect on those talks and say some positive things about them, not only because they were great talks and I don't really have much to criticize, but also because I don't want to get tossed off of a yacht later in the after party. Anyway, I did want to say something about those discussions where Dr. Nick started off this morning talking about how the tools that we're using often shape the concepts that we have about our applications. And Matt Wynn talking about hexagonal rails and how that can be a pattern to help us structure our applications in a better and more sustainable way. And Francis doing a great job of talking about values in our community in the context of front-end and back-end applications, and how we have a lot of core community values that really hold us together. And one of those values, I think, is related to testing. In the Rails community, we really have a commitment to spending quite a bit of time testing our applications. And it's so much different from a decade ago when I was working in a Perl programming shop. I'll admit to doing that. It was a company that was pushing millions of dollars in transactions through a system, and I actually got strange looks when I asked to see the test suite. It just wasn't something that people were doing. And in Ruby, we've really done such a great job of coming to a different position in our testing. And at the same time, I feel like there's a lot more that we can do, and that's really what this talk is about. The talks earlier today focus very much on the values that we have and the way that we have built up a lot of great tools, but also how we can adapt those and how much farther we can go. So we've talked a lot about testing recently, and we've spoken specifically about concepts that relate to test coverage. How much should we test? Should we cover something or should we not cover it? And so we've spoken about things in the last few years, concepts like TATFT. DHH, the creator of Ruby on Rails, has been vocal about a certain level of test coverage, and I'll go into that. And people like Kent Beck have also spoken about what they feel comfortable testing and what they don't want to test. So TATFT, if you haven't seen this acronym before, stands for Test All the Effing Time. This is a G-rated talk, so I'll leave the looking up at the rest of it to the listeners of this talk. And I think that there are some merits to this, especially coming from a context where we may not be testing everything in our applications. If you're not doing any testing, then maybe TATFT is not a bad way to start. But it also has certain limitations. I think that specifically I've heard things from our own developers at Stack Builders, where I'm a consultant, and people will say things like, we have like a 1 to 2.2 code to test ratio, and I still sometimes don't feel confidence enough in what we have in our test coverage. And this is really disappointing because I feel like we're spending a lot of resources here, and we're still not coming up with a tool that really helps us out in our development as much as we could. DHH is very vocal about, in one of his blog posts called Testing Like the TSA, about how much we should aim for in terms of our test coverage. And he said, don't aim for 100% test coverage. He says that code to test ratios above 1 to 2 is a smell, above 1 to 3 is a stink. And he says, you're probably doing it wrong if testing is taking more than a third of your time. You're definitely doing it wrong if it's taking up more than half. I think that in terms of both of these coverage issues, TATFT or the things that DHH is talking about in terms of coverage, they're not meant to be taken at face value. Clearly, there are types of applications that don't fit into these amounts of coverage, and we don't want to say that this is an absolute truth about the amount of coverage that we should shoot for. Kent Beck, who has written a lot about test-driven development and was one of the foremost advocates for doing TDD, says, I get paid for code that works, not for tests. So my philosophy is to test as little as possible to reach a given level of confidence. And he says, I suspect this level of confidence is high compared to industry standards, but that could just be hubris. Now, at this point, we're moving towards something that is not as quantitative as the other approaches, not as quantitative as TATFT, and it's certainly a subjective thing too. So Kent Beck is saying that a level of testing that's appropriate for me might not be appropriate for someone else. And so that's certainly a different direction from the other approaches that try to be sort of universal mandates for a certain kind of coverage. But I still feel that we can go farther than this. And specifically, what I want to do is go beyond talking about strictly coverage, which I feel like we do a lot in the context of testing, and instead talk about different patterns and ways of shaping our test suite so that it becomes easier to work with. And we have lots of ways, lots of concepts that are useful for talking about shapes of production code. We have things like dry, don't repeat yourself. We have solid, and we have lots of different design patterns. And despite what people like DHH say about how design patterns can lead to a certain sort of pollution of your application if carried too far, they are still useful in trying to figure out a beneficial shape of an application, or in trying to articulate what's wrong with a certain application that's become difficult to work with. And despite this, we're still kind of staying at the quantitative level with a lot of our talk about testing. So in shifting this discussion, and I'm not the first one to do this, but I think that it's still useful, since this is something that I've found is useful in a lot of our client projects. I want to talk about some concepts that we can mobilize to help make our applications more habitable. And habitability isn't a new concept with software either. And in fact, there's a book by Richard Gabriel called Patterns of Software, Tales from the Software Community. And he says, habitability is one of the most important characteristics of software. It enables developers to live comfortably in and repair or modify existing code and design. And I think that this is really something that we can shoot for not just in production code, but with our test coverage as well. Like I said, there are lots of cases that I've seen where we have a high degree of coverage and a low level of comfort, or also, of course, a very sparse test coverage and little comfort there too. So what I want to do is build concepts in order to move us forward in organizing our tests in better ways, to make them more habitable. And I want to think about what concepts we have right now. And I think that it's important to realize that the concepts that we have about test coverage are always going to shape the way that they're written. And Dr. Nick mentioned earlier that the tools that we have shape the way that we think, but there's also a concept that we have that shapes the tools, right? Every single tool that we use has a certain kind of concept that has been behind the design of that tool, and then that in turn affects the way that other people are using it and the concepts they have about their code. And in the context of development, we focus so much on this notion of coverage that a lot of times that's our concept. We need a test here, we don't need a test here. So going beyond this, I've thought about a notion of CUPID, and I think that we need to show our tests some love. And so in the tradition of things like solid, I'm trying to create an acronym with concepts that aren't entirely my own, but which I think are useful in creating sensible tests. So I'm going to go over the acronym first, and then I'm going to go over some examples before we open up the floor to discussion. The first part of the acronym that I want to discuss is C, and this stands for consistent distance. And so in our test suites, we have things that we call acceptance tests that are often end-to-end and integrative. And in these tests, we don't want to stub. They should be interacting with the system like a user would. So that could be clicking around in a browser, clicking around in a graphical user interface. And that's the way that we should be interacting with the system. We also have unit tests, which try to isolate a specific module or class that is under test. And the goal of this, in a book that Matt referenced earlier called Growing Object-Oriented Software Guided by Tests, or the Goose book, as you refer to it. And I'm not going to go into that too much in this presentation because he already talked about it some, and because it sounds a lot better when it's done with a Scottish accent. But I think that it has a lot of great ideas, and one of the things that Matt called out is that it talks about the fact that the important thing is not so much the contents of our classes, but the relationships they have with other classes. And with our unit tests, this is very much what we're trying to draw out. But the notion of consistent distance, when carried further, I think means that in things like acceptance tests, we shouldn't be going under the covers and doing things like stubbing, right? And this is something that I know a lot of people have been doing with their tests, and it's something that's mentioned in the RSpec book. But still, I see a lot of this happening, especially with tools like VCR. But I'll come back to that in a moment. I think that largely our tests should be unstubbed. And part of this relates to making the dependencies of our classes explicit. Going back to this concept in the Goose book of driving out the relationships between classes. And I think that when you use things like mock objects instead of stubbing things on a particular class, these relationships become a lot more clear. There's a kind of an addition to this rule that says that you shouldn't stub anything that isn't yours. And I think that also goes under this concept of trying to make your tests unstubbed. Your test should be pyramidal, and this is something that Brian Helmkamp mentioned when he was writing something about this presentation. He said that I should mention the test pyramid, and I think that's a really great suggestion, and this certainly does help to clear up a lot of confusion about test suites. And I've seen that in a lot of test suites, instead of let me describe the pyramid first. So if you can read this text, up at the top it says end-to-end acceptance testing. And so this should be like your feature tests and tests at that level that relate to your system by the interfaces. So by the graphical user interface, by a web browser, and on the other side in terms of the services that you're connecting to. Below that, you have the integrated subset tests, which is trying out a certain collection of the objects in your system in relationship to each other. And down on the foundation of the pyramid, you have the unit tests. And the unit tests, it's very important to emphasize, are the foundation of the pyramid. So there should be more unit tests proportionately to the tests that you have at the acceptance level. And if you look at most of the books on testing, they'll talk about this testing cycle. And I think that a lot of us are doing this, but with a focus on BDD and doing things at the acceptance level, I think that maybe some of the gist of it might be getting lost. You should generally be writing something like an acceptance test first, and then iterating and then watching that fail, and then iterating on a feature primarily by creating unit tests until you reach a point where the acceptance test is passing. And if you do that, you'll almost naturally have a sort of a distribution like this, where you created your one acceptance test, and you created a bunch of lower level tests to support that. And that's going to help you in a bunch of different ways. The acceptance tests are generally very slow because they're fully integrative, and they're also less specific. So if you get a failure at an acceptance test, how do you figure out where that is? You oftentimes look at a red dot on the screen and you say, well, that's great. It's either in this component or maybe 12 levels down, right? And that's kind of a painful thing to dig through a lot of times. So in contrast to just using these acceptance tests and having a high degree of acceptance tests, you try to create unit tests for more of a specificity of diagnosis of error conditions. Your test should be idempotent. So they should always pass regardless of order. And your test should also not have side effects. Now, this is something, idempotency is something that's important in computer science and very important in testing. And I think that sometimes we don't pay enough attention to it, even though RSpec has, in the current versions at least, a really useful feature, which is --random. And if you turn this on, it's going to run your tests in a different order on each run. And in my experience, at least, I found that every significantly sized project that hasn't been using --random is going to have 1 or 2 failures that occur when you start running with this flag turned on. Go and try to prove me wrong. If you've got a test suite that isn't doing this, go and try to run it with a -- random flag and tweet to me about your results. But I have found that it is a really good tool to figure out where you have tests that are dependent on state that was changed in another test. Your test should always also be distinct. And I think that in doing test-driven development, a lot of us end up writing more and more tests, but it takes a much more mature vision into the software that you've written to actually go back and delete some, right? And so we should see how much behavior you're testing in unit tests and integration tests and choose one of those. And I would say that most often the test should be focusing on the unit test level, right? So if you have a choice between testing something integrationally and testing something at the unit test level, choose the cheaper option, and that's going to be unit tests. So don't be afraid to delete tests. And try to figure out how many things fail when you change one piece of code. It's really depressing to see a lot of stuff go. So let's review these concepts for a second. We talked about a notion of consistent distance in our tests. We talked about your test being unstubbed. We talked about the test being pyramidal in form. And we talked about the test being idempotent and distinct. And these aren't supposed to be upheld as some kind of a universal truth, but they are things that I found when I consider the way that I'm looking at a test suite and trying to figure out how useful it is, and also when I'm trying to identify why a certain test suite feels like it's burdensome rather than helpful. These are some of the concepts that I mobilized to articulate that. And as software engineers, that's a big part of our responsibility, to not just be able to say, well, that sucks and we shouldn't do it that way, but to actually have terms to articulate why a certain thing is not easy to solve or why a certain set of tools are not useful. So after we've presented those concepts, I want to talk about how we can leverage this in specific code samples. And the first thing that I wanted to talk about is the violation of consistent distance. And so I said that the first thing that we want to look for is keeping consistent distance. So unit tests should isolate a class under test, and they should substitute mocks probably for close neighbors. And acceptance tests should be end-to-end. So you can manipulate the input into them as a user would, and you shouldn't really be stubbing things under the covers until it comes out the other side, which could be talking to a service or whatever. Now, with that said, why is it okay to use something like VCR? And this is something that I've struggled with in a lot of projects. And so if you haven't seen it, VCR is a tool that allows you to stub HTTP responses in an application. And VCR is well written and everything, but I often run into a lot of pain in projects that are using this. And it took me a while to think about why this is. And I think that one of the ways that we can understand the pain that we're experiencing, or the least that I have in projects that I've worked on when using a tool like this, is because it violates a principle of consistent distance. You've, on the one side, perhaps got an application test where you're running Selenium, and you're clicking things in the web browser, you're doing stuff in a graphical user interface, and on the other side, what's happening here? You've used this tool that replaces the other end of your application with a black box. And this, to me, is not doing this end-to-end testing. If you actually have a problem and you have to look up what's on the other side, with the canned responses, you end up looking through YAML files and encoded HTML inside of that. And that can be difficult to work with. So what's an alternative to this? VCR is a stubbing tool, and as I've said, I don't think that stubbing belongs in end-to-end acceptance tests. It's better to have specific tests that connect to external endpoints or to provide a fake service. So this is something that we started doing internally at Stack Builders, and I later on found that somebody at Pivotal was doing something very similar, and they wrote a blog post about it with a code snippet they used. You can set up your own fake service. So instead of just using VCR, which might leverage a library to knock out methods in net HTTP, you can actually use you can do something a little bit more sophisticated, I think, where you basically start up a fake service of your own. So there's nothing to prevent you from using a Ruby thread and starting up a rack server with a Sinatra application or something that makes your external dependency entirely explicit. And although this isn't going to be a replacement for the real thing, it's not a stub either. And you definitely know what this external service is doing if you've written it yourself. Now, this might sound like a bit more work, and it certainly can be, but in a sense, VCR feels to me like cheating. And you're basically recording these sessions, and you have them appear invisibly in your application. And the alternative that I'm proposing here is not creating a fully fledged sandbox with all of the state-maintaining features of an API like Google AdWords, but just creating something that preserves enough of the semantics and the API syntax to get you through and to make you believe that it's a real thing for most cases. You usually don't even have to save state in it. So this is a packaged version of what we came up with on my GitHub repository called Shamrock, with the emphasis on the sham because it's a thing for fake services. This is the second problem that I wanted to talk about is with stubbing instead of mocking. And in this example, and I'm very sorry about the low contrast between a couple of those colors there, but basically what's happening here is that you have a class that you're passing, a balance calculator class, and internally it's going and it's retrieving a few accounts, and on those accounts it's going to calculate the balance. These two lines here are doing stubs, where you're saying don't actually call that method, just return a few hard-coded accounts. And then you're saying the balance should be $30 or whatever. Now, this is, I think, an overuse of stubbing. These methods, like retrieve account info and retrieve account type, may actually be private methods, in which case you shouldn't touch them, right? If you do, you're breaking the encapsulation of the class, which you don't have a right to do in your application code, and which you shouldn't be doing in your test code. Because your test should be making explicit the external dependencies of your class and the way that it should be called. So we can think about some other options of doing this instead of just stubbing out the methods inside of the class. Maybe we can pass the accounts to the initializer or something like that. But oftentimes what we want to do is to use mock objects instead. And so I think that mock objects are really underused, especially when we've got great frameworks like RSpec that make things like stubbing and mocking on existing classes so easy. And you don't find bugs with those anymore, and they really help out to just stub a certain method on a particular class. But the benefit, which is using a mock object, is that you can be very explicit about all the methods that it responds to. And you can say this is exactly the kind of interface that the classes you're passing to this thing should have. So I think that stubbing can lead to complex test setup, and it doesn't help you to make your dependencies explicit enough. The other thing that I want to talk about is stubbing things that you don't own, right? And I mentioned that you shouldn't stub things that you don't own. And this is an example of that. This is actually from Shamrock, the utility that I mentioned to use fake services instead of using something like VCR, which just stubs out HTTP responses. And as I said, it basically just starts a rack application that is going to be in a separate Ruby thread, and your test suite is your application is gonna call that other thread as your tests run. And so this is all it takes. You do a thread new, and you say a rack handler or WebBrick or Mongrel or whatever, and you say run with a rack application that you give it. And if you haven't created a rack application before, it's very simple. It's just something that responds to calls. So it can be a proc, and then you return back some kind of a response. And so that's all there is to it. And that can be a Sinatra app too or something. So the problem here is, what do you do if you're going to try to run this in a test? All of a sudden, you've got a stub, like you can stub rack handler WebBrick .run, right? You can do rack handler WebBrick .stub run and return whatever. And it makes the test a little bit stranger to write, and you're also coupling to a specific implementation of an external dependency. So what can you do instead of this? One of the things that you can certainly do is to use dependency injection. And this is something that people talked about maybe a lot more in Java because it was tougher to do there. And you needed to have things like frameworks to help out with this. But instead of stubbing the rack handler web brick, you can just pass it into the initializer, right? And that way, one of the benefits is that your tests become, it's much easier to use a mock object in your test rather than having to stub something that isn't yours. Another side benefit is that your code becomes less coupled, and it makes it much easier for somebody else using your library to pass in a different kind of handler if they need to. So don't be scared of dependency injection, and it helps out in a lot of cases, especially in testing. You can provide defaults, so you don't even have to affect the signature that a lot of other callers of your class use. And I found that I'm using this more and more as I write more Ruby. So I think that in particular, this is better for harder dependencies of your class. So if you have something like a web handler, an HTTP handler, try using this to see if it reduces the coupling. Another problem that I've seen relates to the test pyramid. And we talked about the ideal test pyramid shape being the end-to-end acceptance tests at the top in a smaller proportion to the unit tests on the bottom forming the base. And what I see in recent test suites that I've looked at in a lot of different Rails projects is quite the opposite. You see a high proportion of end-to-end acceptance tests which run really slowly. I've talked to lots of people who have test suites that run 2 hours, 2.5 hours, that frequently happens. And I don't see too many Rails projects that have test suites that run in less than 20, 25 minutes. That seems to be a pretty common figure that I've seen across some kind of medium, smaller size Rails apps. So this is really problematic. And it's hard to say exactly why this is happening. Maybe it's because of the fact that we're emphasizing things like BDD. So the way that we think about testing is, as it should be, as a user of the system. So we're saying, as a user, I would like to go to the front page of the site and log in. And that's kind of become our default language for talking about testing. And so we end up writing a lot of these acceptance tests that take this shape and emphasizing those rather than unit tests that interact with the system at a lower level. Maybe it relates to the fact that JavaScript is hard to test integratively, as people have mentioned in these talks today. And it certainly is. We've got things like Jasmine and other frameworks to test strictly the JavaScript component of our applications. But when we actually try to test that integratively, we don't really have a great way of doing that, except with something like Selenium and using our integrative test suites. And so the end result is that a lot of times we end up getting stuck on this end-to-end acceptance testing level and not getting enough unit tests. And this makes our tests run longer and longer, and it makes them less useful because when something breaks, you don't know in what level that's occurring. So the answer to this is to kind of reverse it and to say when you've got an option, make a unit test instead of an acceptance test and try to turn this around. Non-idempotent tests. I've seen this in a lot of test suites as well, and as I mentioned, the cure for this is rather straightforward by using something like -- random, but it happens in a lot of cases. This is one that I actually found in a project that I worked on. And it's hard to read. I'll just read it for you. It's only one line. Basically, in the middle of a test example, somewhere in this probably 25-minute long test suite, somebody was calling action controller base, and they were setting the asset host to a different asset host to change something. And so this is a global setting in the Rails level. And so I was entirely perplexed about why halfway through the test suite in certain random orders, all of the subsequent tests would be failing because the assets would not be loading. And I was like, what could this be? And finally I did some kind of a binary regression or whatever and spent way too long trying to track down this problem. And I found that a developer had just stuck this in there in one example without realizing that it was causing side effects in a way that would be very difficult to trace down later. So what you really want to do is emphasize things like immutability in your test suite. There are other languages that do this a lot differently than Ruby. I've been doing a lot of Clojure in my spare time, and not as much for client work, but in a language like Clojure, it's going to make this harder to do, right? You've got to be very much more explicit about when you change a value that's global, and that could affect the results in other parts of your program. And Ruby doesn't do that. It takes dynamic programming to a very high degree, and it gives you way more than enough rope to hang yourself with. For better or for worse, that's what we're dealing with. And it's a great language, but it puts more responsibility on the programmer. And that's just one of the things that we deal with. We have to be more careful not to do things like this. Another issue that I mentioned is duplicate coverage. And I have a quote from one of the developers on our team, Alexander de Oliveira, and he said, "In a project that I worked on, one single bug caused 124 tests to fail. I was so perplexed that I couldn't figure out from which bridge to jump from." Who's been in that situation? Who's seen like a single bug that just like totally blows your mind when you change one line of code and all of a sudden you've got a screen full of red, right? This is really demoralizing, and instead of becoming a habitable environment, what we're finding is that the tests really become hostile. They're not helping you anymore. They just make you not want to touch anything, right? And this is exactly the wrong direction to go in. So why is this whole testing thing so difficult? There's a quote that I found from Gerald Sussman, who is one of the original teachers from the MIT CUPID course. And he said that the world is messier in general. There are massive amounts of data floating around, and the kinds of problems that we're trying to solve are much sloppier. And the solution's a lot less discrete than they used to be. And that's very much the case in production code as well as in our application code. And so if you're working on something like Project Euler, just solving these discrete problems in math without external integrations, unit tests are the easiest things to write, and I couldn't think about doing exercises like that without creating unit tests because they just make me go faster. But then you get into a world of mixing JavaScript and Ruby in applications, connecting to external services that you just want to wish away with using something like VCR. You have problems with all of these real-world problems that just really complicate the situation for your tests. So that's I think one of the things that makes testing so difficult, because you have all the problems of the integrations in production code, and it's just amplified when you're actually trying to integrate against your code that's integrating against the rest of the world. So going back to the book that Matt Wynn mentioned, and this is really a great resource. The fact that it's written with Java examples shouldn't hold you back from looking at it. They're really not that tough to approach. They say in that book, we regularly reflect on how well TDD is working for us, identify any weaknesses, and adapt our testing strategy. And I really think that based on what I've seen in a lot of projects that I've worked on over the last few years, that we have a lot of great ideas in testing, and we have a community that is much more vocal and much more adamant about adhering to strong testing practices than perhaps in any other language. And that's something that we can really be proud of, and I think it's really helped out the quality of our applications. But I also think that we can improve it, and my suggestion for improving it is to think about different concepts rather than just strict coverage. Trying to mention something like CUPID, and if CUPID doesn't work, throw that out and build different concepts. So in closing this presentation, I just wanted to say that sensible testing to me is reflexive. And in software, we build three kinds of tools. We build tools for our clients. We build these web applications, or we build these tools for our full-time employers. We also build tools that help us to build these things. That's the kind of tool, I guess, that Dr. Nick was talking about with deployment earlier. They're tools like RSpec or whatever we're using for writing our tests. And we also build concepts. The concepts that we build are what I've really tried to focus on in this presentation. They're not things to be held up as a sort of a platonic ideal. They're not things to be passed down from an ivory tower to say this is a blueprint for the way that you should write your application no matter what it does. But they're thinking tools that we can adapt in order to solve particular problems that we have. And I think that in closing, I just wanted to ask you what concepts you're mobilizing in your testing. And are they the ones that you're happy with, or can we improve them and change them? Thank you.